everyone. Today we will introduce optical fiber. First of all, let's look at the structure of optical fiber. The central cylinder is called the fiber core, which is made of some kind of glass or plastic. Surrounding the core is a cylindrical jacket, called a cladding, made of glass or plastic with slightly different characteristics from the core. The refractive index of the core is slightly larger than that of the cladding, and the outermost layer is usually covered with a sleeve. The optical conductivity of an optical fiber depends on the optical properties of the core and cladding, while the strength of the core is maintained by a sleeve, which is usually made of plastic. The propagation of light in optical fibers can be elucidated through the concepts of light or light waves, including the notion of total internal reflection, light interception, the electromagnetic wave phenomenon of light, and cylindrical dielectric waveguide of optical fiber. Then, let's learn the principle of light propagation in optical fibers. We will discuss the basic principles starting with the light propagation in layered medium. When the diameter of optical fiber is much larger than the wavelength of light, the light propagation can be discussed by geometrical optics. According to Snell's law, light will refract at the interface of two different media. The refraction law is shown in the formula, in which alpha and beta indicate the incident angle and refractive angle respectively, and N1 and N2 represent the refractive indices of medium 1 and medium 2 respectively. The refractive index of a medium is defined as the ratio of the speed of light propagation in vacuum to that in the medium. The higher the refractive index of the medium, the slower the light propagates in the medium. When light propagates from a dense medium with a high refractive index to a sparse one with a low refractive index, total internal reflection occurs. This means that the reflected light remains within medium 1, illustrating the principle of light propagation in optical fibers. According to the principle of total internal reflection, the refractive index N1 of the fiber core will be larger than the refractive index N2 of the cladding. The two rays shown in the figure, one of which represents some rays whose glancing angle, complementary to the incident angle, theta, is larger than theta c, critical angle. These rays cannot propagate far because they are refracted from the lead into the cladding. Another ray represents some rays whose glancing angle theta smaller than the critical angle theta c. Whenever the light is incident on the interface between the core and the cladding, these rays have total reflection, so these rays have been intercepted in the fiber, producing multiple total internal reflections on the interface, propagating within the core along a zigzag route. These rays will transmit through the fiber core without loss until it reaches the end of the fiber. Next, we will learn the characteristics of transmission in optical fibers. The transmission characteristics of optical fibers is crucial in optical fiber communication system, which directly affects the maximum transmission distance of the transmission system. It includes the loss and dispersion characteristics of optical fibers. When transmitting high-intensity power, the nonlinear effect of optical fiber needs to be considered. 1. Loss characteristics of optical fibers. When light wave propagates in optical fibers, the optical power decreases gradually with the increase of transmission distance, which is the transmission loss of optical fibers. The loss of per unit length of optical fibers is directly related to the transmission distance of optical fiber communication system. There are many reasons for transmission loss, including the loss from the optical fiber itself, from coupling between the optical fiber and the light source, and from connections between optical fibers. Here, we simply analyze the loss from optical fiber itself. There are two kinds of reasons for the loss from optical fiber itself, namely absorption loss and scattering loss. Absorption loss means that when light waves pass through optical fiber materials, a part of light energy becomes heat energy, resulting in the loss of optical power. There are many reasons for absorption loss, but they are all related to optical fiber materials. Intrinsic absorption occurs because of the inherent absorption of the basic materials of optical fibers and is not caused by impurities or defects. Besides intrinsic absorption, impurity absorption also occurs, which is caused by impurity of materials and imperfect production process. The most serious loss is caused by excessive absorption of metal ions and hydroxide ions from water. The higher the impurity content, the more serious the loss. Scattering loss is caused by scattering of light conducted in optical fibers due to defects or inhomogeneity in material, shape, and refractive index distribution of optical fibers, hence it is called scattering loss. 2. Dispersion characteristics of optical fibers. The dispersion of optical fibers causes spreading of input pulses in the transmission process, leading to intersymbol interference and an increase in error rate, thus limiting the communication capacity. So what is the dispersion of optical fiber? The emitted light from an actual light source is not monochromatic or of a single frequency, but has a certain wavelength range, which is called the spectral line width of the light source. The signals transmitted in the optical fiber are composed of different frequency and different modes, each with different propagation speeds, which will cause the shape of the pulse waveform to change, that is, the optical pulse transmits in the optical fibers. With the increase of transmission distance, the pulse waveform spreads in time, which is called the dispersion of the optical fiber. Dispersion in optical fiber can be categorized as follows: mode dispersion, material dispersion, and waveguide dispersion. In this lesson, we have learned the structure, basic principles, and transmission characteristics of optical fibers. You can consult the materials after class to understand the applications of optical fiber. See you next time.